Max, do you have any questions?
Oh, actually, I do have one question.
This is probably the hardest topic at all.
Is number
It'll get better.
Is number 4, can that be an SAS?
Okay, so you do have two sides and you have an angle, but if it's SAS, that means that you'll have two sides in the included angle. So if it were SAS, the angle is between the two sides. That would mean that wherever the two sides are, the angle between them would be the one that you know. So that since that's not the angle that you know, it cannot be SAS.
Bro, all this is just like remembering. Like it's not really math.
Okay, let's talk about the difference between number 1 and number 2. So when you have two angles and a side, how do you know if it's angle, side, angle, or angle, angle, side? Two angles and a side. How do you know which one it is, Diamond?
If the side is included or not included.
Okay, so when it's angle, side, angle, the side has to be between. It has to be included between the two angle measures that you know. So when you're looking at this, it's angle, then a side, and then an angle. Okay, it's always in that order. So two angles and the side that's between them. Whereas on this one, it's two angles, oops, sorry. It's two angles, and then the side is not the included side, it's the one that follows, right? So it would go angle, angle, side.
So if it's a cuss word.
Well, there's lots of cuss words that it's not, but yes. Yes, angle, side, side doesn't work. So for number 4, H stands for what? Hypotenuse. So what kind of triangle has a hypotenuse? Right triangle. So HL means that you have the hypotenuse is marked and you have one of the pairs of legs. So this one you have those two legs and they have to be right triangles. Okay, that one is not SAS again because we don't have the included angle. We would have to know those two angles for it to be SAS. Other questions on 1 through 6? What in the world? Why are you banging your head with that? Isn't that something that goes with your feet?
Yeah, I do it last. Because I like broke my face.
Is it like a brace type thing?
Yeah.
Okay, 7 through 12. So side, side, side should be the easiest one to recognize, right? You don't have to know any angles. If you have all the sides matched up, then it's side, side, side.
Yeah.
Number 8, you have all the sides. Okay, so since you have that pair of sides, and you have the second pair of sides, and you have the third pair of sides, and it's side, side, side. If you know all the side lengths, the triangles have to be congruent. What if you know all the angle measures? Then they're similar. They might be congruent, but they don't have to be. So keep that straight. If I give you 3 sticks of a fixed length and then you give them to somebody else, there's only one way that you can put them together to make a triangle. But with the angle measures, remember that if you know all the angles, if you know all the angle measures, that does not necessarily make them congruent because it could be that one is larger or smaller proportionally than the other one. Okay, so if I shrink it down, then it would be, yeah, those are similar. They're not necessarily congruent. Sorry, I'm trying to grab that and I can't. So if the angle measures stay the same, I kind of twisted by accident. If the angle measures stay the same, which those angles are all matched up, but the side lengths have changed, then they'll be similar but not congruent. So there is no angle, angle, angle congruence, but there is a side, side, side congruence. Okay, remember that vertical angles will always be congruent, and if they're right angles, they're still congruent angles. So don't think that just because you have right angles that it's necessarily a hypotenuse leg. Right, this is an example of one, number 9 is an example of one where you have right triangles, however, they're not congruent by HL, they're congruent by side angle side. Where is the hypotenuse of for number 9? Where are the hypotenuses? Yeah, like the top and the bottom, right? Remember that a hypotenuse is across from the right angle in a right triangle. So those lengths you don't know. So it can't be HL because the hypotenuses are not marked. Yeah, so for HL, you have to have 2 right triangles where the hypotenuses are marked congruent and then one of the other pair of legs. So it doesn't matter which other pair you have, but you have to have the hypotenuse. The hypotenuse is always across from the right angle in a right triangle. Sharon. Okay, and then again for number 10, let's kind of like reiterate that. For number 10, that's going to be angle, angle, side because it's not the included side. Where would the included side be? In between. So if we have a pair of angles there and we have a pair of angles here, if it was angle, side, angle, it would have to be the sides that connect those 2 angles, right? That would be angle, side, angle. But because our side is not between them, our side is outside, it's not the one between, it'll be angle, angle, side. If you write side, angle, angle, I'm not going to count it wrong, it's just kind of not standard. Right? This is the standard way of writing it. Okay, but if you had those, again, that would be angle, side, angle. Okay, any other questions through number 12? Okay, and again, angle, side, side in general doesn't work, but for right triangles it will, but you don't call it angle, side, side, you call it hypotenuse leg. Okay, so don't forget about HL because sometimes students are like, oh, it's ASS, doesn't work. Remember, if they're right triangles, it will make them congruent, but it's HL. Okay, for the congruent statements, make sure your vertices match up. So you might have something different than I do, like maybe you have triangle ZXY. That's okay as long as the second one matches. So if you have something different than I do here, you're going to have something different than I do on the other side, but it's not necessarily wrong. Okay, but look at Z is the one that has 2 marks on it. That means it has to go with R. Okay, and then X has 3 marks on it in the left triangle. So same thing in the other triangle. So X is actually going to match to itself this time. And then the last one's better match up, which they do a single mark on Q and a single mark on Y. So Y should go with Q. Okay, you can also check your answer if yours is different than mine by, like, let's say you have YZX. If you have YZX, then if you go QRX, like do the same pattern and it should match up. So you might have a different congruent statement than I do, but it could still be correct. It just depends on the order of your letters because the vertices have to match up. Now again, on this one, notice the X matched to X because they both have 3 marks on them. However, on this one, notice that in the triangle on the left side, R has a single mark. The triangle on the right side, which angle has the single mark? Q. So R is not going to R and Q is not going to Q. So be careful about that because you want to make sure that you're not assuming that the R, like the letter that's the same, always goes together. So for this one, if I'm just doing like single, double, triple marked angle. So over here, single is R, double is Q, triple is B. Okay, on the other on the other triangle, the single is Q, and then the double marked is R, and then the triple marked is P. So again, because the vertices don't match, you're not going to have R and R together, and you're not going to have Q and Q together. Okay, so do not assume that the same letter has to go in the same spot. In other words, this line right here is not a line of symmetry. You wouldn't be able to just fold it. Like if you tried to fold that over, it's not going to match up, right? Because see how those angles aren't the same and these angles aren't the same. So depending on how the markings are, it might be possible that R and R are matched and Q are matched, but in this particular picture, they're not. Okay, so just watch out for the markings on the angles to make sure you know the correct order to match them up. Questions on those two? Well, that one, number 13. Is what? Yes. It is over here. Is it Wednesday over there? Uh-huh. Okay, on the next side, the next page, it's asking you to state what else you would need to know. Okay, this is not just mark it on the picture. This is actually write down the statement of what you would need to know. Okay, so like for the first one, for hypotenuse leg, we already know that both of those angles are right angles because linear pairs is supplementary. And then we know that the IH segment is congruent to itself by reflexive. What you would need to be given would be that the hypotenuses are congruent, right? So for HL, you already have the pair of legs. You already have that it's a right triangle. What you don't have are the hypotenuses. Okay, so you would need to know that those two segments are congruent. Pay attention to the order. You might have JI as long as you have UI. Okay, J to I is going to match with U to I. So write this, the missing information. Don't just highlight, don't just mark it on the picture, highlight on the picture. You need to actually write a statement. Now, notice that on number 16, there's two different things stated. So there are two different things stated because if I told you that the orange angles were congruent, that would make the triangles congruent by angle, angle, side. But if I gave you that the gray ones were congruent, it would still make them those triangles congruent by angle, angle, side. Okay, so there's two different possibilities. So it's saying what is the required information to make the triangles congruent by the angle, angle, side method? Well, if I told you just this, that would be sufficient. Or if I told you just this, that would be sufficient. Okay, but don't assume that just because, like if you only wrote one of these, that means that you have to know that in order to make the triangles congruent, and you don't have to know that. You could know either of those parts of information. So make sure on that one, and this happens with angle, angle, side. With angle, angle, side, because there's two non-included sides, that kind of gives you two different possibilities. So for number 16, there should be two answers. Okay, did you have two answers for any other problem? There should be one more. There's one other problem that has two different answers, like number 16 does. Look at the ones below. Any others that would have two answers? I told you that this happened with an angle, angle, side. 19. I agree. Okay, so for angle, angle, side, either of those pairs of angles would give you the triangles congruent by angle, angle, side. Now, something I also want to discuss here is that notice that sometimes I have just one letter to name the angles and sometimes I have 3 letters. Why is that? So looking at 18 and 20, why on number 18 can I just use an angle C and angle U, whereas on number 20 I have to use the long name? What's the difference? Jake? Okay. There's actually 3, right? If you just said angle Q, I wouldn't know, did you mean that angle Q, or do you mean that angle Q, or do you mean this angle Q, right? So if there's multiple angles that have the same vertex, then you need to use the long name. It's magic. I know magic. It's this little thing up here. You can turn on or off the laser tail. So if you turn it off, it's just like a pointer type thing. But if you turn it on, it like hovers. You can change the color, whatever you want it to be. But that way I don't have to erase what I'm writing. I have the special math teacher version. Maybe it's user error, I don't know. It could be the version of Notability you're running. Maybe if you haven't updated, you don't have that. Or maybe you just can't find it. Is it really not there? Yeah, you might just need to update Notability. Okay, so again, when you're naming these, if you say angle C, I know exactly what angle you're talking about. If you say angle U, I know exactly what you're talking about. If you wanted to use the long name up here, you can. It's just not necessary. Now, when you're naming the angles down here, make sure that your vertices match up. So if you go P to Q to R, then you need to go from W to Q to R. Okay, make these vertices match up with the vertices in the first triangle. On this one, Q and Q goes together and R goes together. So that one is a little different than one up above. Okay, questions on 17 through 20. Grant, how's it going over there? Okay, and then for the last one, you need to be doing distance formula. How many times? 6 times. Okay, so I gave you the distance formula there. You need to make sure that you know how to plug it in and correctly simplify that. The ones that are square root of 18, make sure that you simplify any of those radicals, as that's the only one that will break down. The other ones are primes. If you don't have the work written out for those, you can take a picture of that if you want to, but you need to make sure you can show me how to calculate that. I know that sometimes I might write more than you necessarily need to write, like that one. You maybe don't have to write all those steps, but that's just so if you have the wrong answer, you'll be able to backtrack and kind of figure out what's wrong.
How do you know the triangles are congruent?
The triangles are congruent by side, 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 because you just calculated all the side lengths. Does that make sense? Okay, so you've got triangle ABC, and you've got triangle DEF. And you just showed that AB is root 17. Scroll in here a little bit. AB is square root of 17, and so is DE. So those are congruent. And then you showed that BC was 3 root 2, and so is EF. So these are congruent. And then the last segment, that one is square root of 5, and this one is square root of 5. So the triangles are congruent by side, side, side. Okay, so you're doing 6 distance calculations. You can't really do that with angles. It doesn't work the same way with angles, but you can find segment lengths by using distance. Max? Okay, so let's say it's like square root of 20. 2 ways you can do that. You can either do a little factor tree, so like 4 and 5 and 2 and 2. And then remember, the partners come outside. So a 2 comes on the outside, and then you have a 5 left over, so it stays underneath the radical. The reason that works is because you're really thinking this, the other way to think of this is like, just break it down into a perfect square that you can think of, and then whatever's left over. Square root of 4 is 2, so 2 root 5. It'll give you the same thing. The reason that works is because This is two of those is like when you take the square root, it just becomes one of them, right? Yeah, so just either factor tree and factor it down, or else take out a perfect square. You do want to make sure you get the biggest perfect square, because like let's say it's square root of 80 and you do square root of 4 and square root of 20, you'll have 2 root 20, but square root of 20 breaks down more. So if you don't get the biggest perfect square, you might have to do that more than once. So this would be like square root of 4 square root of 5, and then 2 times 2 root 5 would give you 4 root 5. Square root of 16 goes into 80. So if you did it in one step, it'd be like that. Okay, any other questions on homework problems? Okay, let's go ahead and stop there and break for lunch. Let's do the rest of the problems on those notes from yesterday that we didn't do yet. So some of these will be real straightforward and some of them might be a little bit harder. So I want to make sure we talk about these. Okay, so let's see. Grant, tell me why those triangles are congruent.
I know why.
Here's your options. Side, side, side. Side, side, side should be the simplest one. Okay, so if you have all the sides marked, not even anything to do. Side, side, side. Okay. How about this one? So do we have everything marked that we need, or do I need to mark anything else?
We can mark the middle one for transitive property.
It's not transitive. What is this?
I mean,
Reflexive.
yeah,
Okay. So if I ask you to explain, you know, how you know things are congruent, then that one you'd say reflexive. Is that enough then to make the triangles congruent? Reason?
Side, side,
Side, side, side. Okay, how about in the next row, the middle one? We didn't get to that one. Lily, tell me what you would do with that one. Okay, so let's check. What does H stand for?
hypotenuse.
Hypotenuse. Lily, where's the hypotenuse of this triangle? Okay, does it have markings on it? So it can't be HL, even though they're right triangles, the reason's not HL. So the other things can apply to right triangles. What else do you have marked? So if you just consider the right angles to be congruent angles, don't even worry about the fact that they're right angles.
Side angle side.
So Lily, do you agree with that or no? Yes. Okay, so HL only works on right triangles, but not every pair of right triangles are congruent by HL.
Right.
So in this case, you're just using the right angles to be congruent angles. Okay, side, then the angle, then the side. Okay, two sides and the included angles are congruent. Yes. It's not just a small emergency, it's a big emergency. Yes, go. All right, when you see parallel lines, so these are the ones that are usually a little bit more complicated. When you have parallel lines, the first thing I would recommend you do is highlight the lines so you can focus in on two lines in a transversal. Okay, so these are your parallels, that was given. And then it says segment CD bisects segment AE. Kara, what does that mean for segment CD to bisect segment AE? What can I mark? AC and CE are congruent, okay? And the reason for that is definition of, they're not angled, but it's a segment bisector. You can say bisect, bisector, bisects, whatever you want to say, definition of bisect, or segment bisector, whatever you want to say. Okay, and then you were also given the angle E is congruent to angle BCA. So angle E here and angle BCA there. Now again, notice that they used one letter for angle E. They used 3 letters for angle BCA. That is because why, Braden? So ACB is the same as BCA, right? Why can't you just call this angle C though?
That's for the other one too.
There's lots of angles, right? So this one is BCA, but if you said angle C, I didn't know if that's that one, or if this is angle C, or if that one's angle C, or actually even this one, or that one. Like there's so many angles with vertex C, right? So angle E, I know exactly which angle you're talking about. There's only one angle that has a vertex of E. So that one we know we can just use one letter and we'll be good. But for the second one, if you were naming that, you need to call it BCA or ACB. Okay, we haven't really used the parallel lines yet. You need to decide which transversal is going to be helpful. One of you Zoomer people, I want to know, is option number 1 a good transversal? Or is option number 2 a good transversal? Or is option number 3 a good transversal? Which transversal do you think we should use? We're trying to get 2 angles that are inside the triangles. This is for
No.
Claire.
Number 1.
Yeah, number 1.
Gabe, which one?
The first one you drew.
The first one. Okay, and somebody else said something.
I said number 1 too.
You said number 1. Okay. So if I draw number 1, I could use this angle here, congruent, like an alternate interior would be like that one. But that angle is not inside of the other triangle. Right? So let's try to find a transversal that would give you 2 angles that are actually both inside of the triangles.
It's a straight line.
Well, they're all straight because they're lines, but I know what you're saying. The horizontal one.
Yeah, horizontal.
Okay, so if we make this our transversal, just focus in on the parallel lines and the transversal. So I'm going to just like completely ignore, just don't even look at those for a minute. So where are the congruent angles? What kind of angles are they that are congruent? Consecutive interiors are supplementary.
Isn't it corresponding?
Corresponding. Okay. Now, the corresponding angles that are congruent would be angle A. And then again, you cannot call that angle C. You'd have to call it angle DCE. All right. Derbla. Do we have enough to say the triangles are congruent? What's the reason? Angle, side angle. Okay, so we have 2 pairs of angles. There's one pair. There's our second pair. And then we have the included side. So angle, then a side, then the angle. Angle, side, angle. Jake, are you with me? You're awfully quiet and facing the other direction. That does not make me believe that you're really doing what you should be doing. Okay. On this one, what do those arrows mean?
Parallel.
Okay, we have two different pairs of parallel lines this time, right? So let's look at one of them at a time. So let's do the horizontal ones first. And then there are 3 different lines you could consider a transversal, but we want one that's going to create angles inside the 2 different triangles. Okay, so we're going to use this line as our transversal. Let me change colors. We're going to use CB as our transversal. Where are the angles that would be congruent? Jake, name them. ABC. Okay, and if you say ABC, you have to go in the same order. It'll go that way, right? DCB. With congruent triangles, we're kind of picky about the order that you say things. But yeah, those 2 angles will be congruent. What's the reason? If then? Okay, if lines are parallel, then alternate interior angles would be congruent. Okay, do we have anything else that we can mark right now? So question, do we know that segment AB and segment CD are congruent? Do parallel segments have to be congruent? So could I do that?
No.
Here's two segments that are parallel. Oops, sorry.
Yeah.
Here's two segments that are parallel, but they don't have to be congruent, right? Like think of like a trapezoid. So be careful that you don't think that parallel means they have to be congruent. Are there any segments that are congruent? There. Okay, let's do the reflexive situation there. So reflexive. And I think we've gotten everything we can get from those lines. So let's jump to the other pair of lines. So if we look at these lines being our parallels, same transversal. If you want to get rid of the green, if that helps you focus on those angles, that's fine. Okay. Drew, what angles can we get from those two, the orange lines with the transversal? B, D, C. Okay, this one over here is not using the transversal, right? That's using this parallel and this line over here. I need you to use the orange and the purple. So I'm going to actually get rid of the other ones for a minute and see if that helps. So if I don't even look at these parallels here. Okay, where are the angles? I can even cover that up. Where are the angles that are formed with the purple and the orange? ACB and DCB would be over here. Oops, would be over, oh, sorry, I'm still in white. DCB would be over here. So ACB, say it again. BC, this one. Is that the one you said? Okay, this one is not using the orange parallel lines. I agree with the first one. Where's the angle that's congruent to that one? The DC, this one over here. Okay, that's not using the purple line either. So if you just trace this, where is there another angle that's using CBD? Okay, so back out here. Again, you could leave the green ones highlighted if you want to, but this second pair of angles would be those two are congruent. It'd be the same reason, right? Those are also alternate interior, just using a different pair of parallel lines. Okay. Grant, why are those triangles congruent? Yeah. Okay, how do you know whether it's angle side or whether it's angle side angle? So here's two angles. You got two angles that are congruent, two angles in a triangle. Where is this side? So if the side's between the angles, it's angle side angle. And if the side's not between the angles, then it's angle side. Which one is it? Should be angle side angle. Okay, so be careful with the ones that are two angles and a side, because you need to pay attention to where the side is in relation to the two angles that you know. Okay, that would be angle side angle. Okay, Kendall, what can we mark that's not currently marked on this, on that diagram?
For the next one,
Yeah.
You can say the TR is another side, so that makes them reflexive.
Okay, so if we use the reflexive segment here, we can, and also be careful that when you're marking things that you use 1 mark, 2 marks, 3 marks. I don't want you to do that, because that means all three of those are the same. Okay, that's definitely not the case. Okay, so that one is congruent. She said reflexive property of congruence. Okay, do we have enough to make the triangles congruent?
Yeah.
What's the reason? HL. Okay, so remember that you cannot call this angle side side, because angle side side is not a thing.
Right.
But you do have, remember the hypotenuse is the longest side of the triangle that's across from the right angle. Okay, so you have the two hypotenuses marked. There's that hypotenuse. This is the other hypotenuse. You have the H, and then your other pair of sides there is your one of the leg that's congruent. So that would be HL congruence. Okay, and again, you cannot call it angle side side. Okay, and then for the last one, is there anything else we could mark that's not currently marked? Reflective, okay. Yeah, I'm gonna make sure I put 2 marks on that. Is there a third sides kind of thing? So if you know 2 sides in a triangle are congruent, does that make the third sides congruent? Yes?
Yes, it does.
Yes, it does? It does not?
I think it does.
So let's draw.
Theoretically, I feel like it's
Here's a segment. Okay, here's a second segment. And then I'm gonna draw the same segment length over here. But I'm gonna draw this segment at a different angle. So I'm gonna turn it like that. So even though those are the same and these are the same, this one's gonna be longer, right? Because I kind of opened up that angle.
Yeah, you
This
did
one'll be
say that.
longer.
You were like, if you give us 2 sticks that are the same size, one of them should be like this, the other one should be like that.
That's what I said.
Yeah.
Let me make it better to.
Robert Diamond? You have what? Oh, you said Corona.
So be careful, because if you know 2 segment lengths and 2 triangles, the third segments don't have to be the same. There is a third angles theorem because the angles have to add up to 180, but there's no like magic number for the segments adding up to a certain number. So just because 2 sides are the same doesn't necessarily make the third ones the same. Make sure you're not assuming midpoints. Do we know that these are right angles right here?
No.
No. Make sure you're not assuming perpendicular or right angles. Okay, make sure you're not assuming midpoints. What about up here? Can I mark those congruent? We don't know, right? So be really careful that you don't just make things up. Every time you mark something, there should be a specific reason. And if I don't tell you midpoint or bisector or perpendicular or something like that, then you cannot assume that those things would match up. So yeah, that's right. That's for reflexive. Okay. So don't know. All you have is 2 pairs of segments. You don't have any angle measures. It's not going to be sufficient. So no, I can't hear it. Singular? Similar. We would not even know that they're similar because, again, if all you know are 2 pairs of congruent segments, the triangles don't even have to be the same shape. Okay.